Today's lesson is about empirical and molecular formula of compound. First of all, what do we mean by empirical formula? First, we have to learn about the molecular formula. Molecular formula is the actual formula of any compound. As you can see, we can as the actual formula of any compound. This also shows the number of atoms of each element, the real numbers of atom, which makes the molecular formula or which makes up the molecule or the formula unit as we know it. For example, we have the molecular formula of glucose. The molecular formula of glucose is C6H12O6. Now about the empirical formula. Empirical formula is the simplest ratio between elements of compound. As we've learned, glucose molecular formula is C6H12O6. Now, as you can see from these numbers, this is not the simplest ratio between carbon, hydrogen, and oxygen. We can make it more simple, of course, by simplification. Simplifying means you can divide. So in this case, we will divide by 6 and turn it to CH2O. This is the empirical formula of glucose, which is the simplest formula of compound. Or we can say that it shows the lowest whole number of ratio of elements in one compound. As we can see, carbon or in glucose C6H12O6, and this is not the simple ratio between the three elements. So we can simplify it by just simply dividing by 6. So we divided by 6. When we divided by 6, it became CH2O. So this is the empirical formula and this is the molecular formula. Okay, now we have to learn how can we determine the molecular formula. But first, to determine the molecular formula, we need to determine the empirical formula, which is the simplest ratio between elements in one compound. We can use that. We can use masses of these elements, or maybe we can use percentage composition of the compound. Okay, now let's try an example using the molecular formula to find the empirical formula. Okay, butane is an organic compound which has a molecular formula or the real number of atoms in one molecule is C4H10. Okay, if you can look, we can make this simple, just divide by 2. So the empirical formula will be C2H5. Now let's try glucose. This one already we have tried. So we will divide by 6. So the empirical formula will be CH2 and then O. Now check for benzene. Benzene also is an organic compound which has a molecular formula of C6H6. Okay, now you can help me. Of course, you will say that we can divide also by 6, so it will become CH. What about the water? Okay, here in water we have 2 hydrogens and just 1 oxygen. Okay, can you simplify that? No, actually this is the simplest form. Molecular formula. This shows us that sometimes the molecular formula is the same as the empirical formula. Means sometimes the simplest ratio between elements in one compound is also the real number of elements in that compound. Now Let's check our answers. Okay, did you check your answers? As we checked, this one is already there. So here we divided by 6, 6. And this is, as we have learned, the molecular formula is the same as the empirical formula, and that works only for some compounds, usually organic compounds, because actually the same number of atoms is also equal to the simplest ratio between atoms in one molecule. Now, this way, we have learned how to find the empirical formula using the molecular formula. But what if we don't have the molecular formula? How can we learn to deduce the molecular formula? We said if we cannot, or if we don't have the molecular formula, so first we have to deduce the empirical formula. And deduce, or to calculate, or to find the empirical formula, we have to have masses of the elements in that compound, and these masses can come in grams or in percentage of composition for these elements in one compound. Now let's see one example. Okay, using the percentage composition, an example. Okay, calculate the empirical formula. EF is empirical formula for the compound that is, okay, these are the elements that made that compound, which is carbon and hydrogen. Okay, when you're doing any example, you have to read it more than once just to realize what is given to you in that example and how can you work it out. Okay, so he needs to calculate the empirical formula, means the simplest ratio of a compound. This compound is made of carbon. Actually, it has 85.6% carbon and 14.4% hydrogen. Okay, to answer this, actually it's very simple. Okay, so you have two elements, carbon and hydrogen. Now, all you have to do right now is write the masses of these two elements. Okay, when you look at the problem, there is no masses, but there are percentages. Okay, simple. When you have percentages, just use these percentages and directly put them as grams. So 85.6% will make it as equal 85.6 grams. Okay, same way for hydrogen. Now you have 14.4%, which will make it 14.4 grams. Okay, now you have the composition have been converted into grams, which is mass. And remember the rule that we studied the previous lesson was about moles. Okay, so these masses you will use them to calculate the number of moles. Okay, as we've learned, N equal M, which is mass, over Mr, which is the molecular formula of each of these elements. Okay, so the mass of carbon actually is 85.6, and the molecular formula from the periodic table of one carbon is 12. Again, same way. So 14.4, which is the mass of hydrogen used in that compound, and actually the molecular formula of hydrogen equal 1. So now we use the calculator to find. Okay, now we have 85.6 divided by 12. It gives 7.13 mole. About hydrogen, of course, it's 14.4 mole. Okay, now you have the number of moles. But these number of moles, okay, here you have 7.13 and here you have 14.4. Still, it's not finished. Okay, we haven't seen in any compound the numbers of the elements in percent or in decimal. So the next step, divide by the smallest ratio. Okay, between 7.13 and 14.4, of course, this is smallest. So we will divide by 17.3. Here is the same, 7.313. So here will be 1. And actually here will be almost 2. So from the beginning, actually this is a ratio. So to conclude, this is the carbon and you have here 1 carbon. Of course, we don't write the 1. And you have 2 hydrogens. So the percentage or the ratio between carbon and hydrogen is 1 to 2. So it's 1 to 2. So the empirical formula of that compound is CH2. Now let's check it, actually more organized way. There. Okay, here it is. You have the carbon. The mass of carbon will be here you have the mass of carbon in percentages simply. It's 85.6, yeah. And here the mass is, of course, in percentage 14.4. So directly we have made the percentage into grams, as we can see. So carbon mass is 85.6, hydrogen is 14.4, and the molar mass of carbon is 12. The molar mass of hydrogen is 1. Okay, here it is. We calculated the number of moles. Of course, divide the mass from the rule, divide the mass over the molecular mass. So it's 85.6, sorry, divided by 12 gives you 7.13, and 14.4 divided by 1 gives you 14.3. Okay. Now we divide by the smallest ratio, as we said, so 7.13 divided by 7.13 and 14.3 divided by 7.3, so actually it's 1 to 2. So the ratio between hydrogen and carbon, C1H2, and this is the empirical formula, CH2. Okay, this is another example. But here we have 3 elements. Okay, so again, here you have two examples, sorry, there. Here you have 2 examples. The first example, calculate the empirical formula of these compound following the percentage. Okay, you have 3 elements there, 32.4 Na and 22.6 sulfur and 45 grams of oxygen, sorry. And this is the second example. Okay, one more thing. For the empirical formula, if you have the empirical formula, we will only add one step for the empirical formula. Sorry, for the molecular formula. For the molecular formula, in the example you will have the molecular formula of the molar mass of the molecular formula. Okay, and this one you will calculate the molar mass of the empirical formula. The ratio between both of them, when you divide, you just multiply it into the empirical formula. For example, we have the empirical formula of glucose, which is CH2O, and when you just multiply the number of that ratio, which is N, it becomes C6H12O6. Thank you for listening. Hope you enjoyed and hope to see you soon.